So we need to be able to change the properties of our polymer so they're just right for how we want to use it. And there's two ways we can do that. We can do that by changing the structure of the polymer itself, or by adding things to the polymer. So here we've got our two polymer chains. Obviously in real life these would be a lot longer. We've got two polymer chains here, and what attracts the polymer chains together are intermolecular forces. So these are the same type of forces that you get in smaller molecules like carbon dioxide. So we've got intermolecular forces, and those attract the chains together. So what we need to do in order to change the properties of our polymers is to change our intermolecular forces. If we make them stronger, the material itself will be stronger, it will have a higher melting point, but it will be stiffer and less flexible. If we make the intermolecular forces weaker, then the material will be weaker, it will have a lower melting point, but it will be much more flexible. And we can therefore design materials that work really well for different uses. Now there's a couple of different ways that we can do this. The first one is called plasticizers. And plasticizers are a small molecule that we add, and it goes between the polymer chain. So those little wheels are going to be our plasticizers. And the plasticizers make the intermolecular forces weaker. That allows the chains to slide past each other like you can see them doing here. And it makes the material much more flexible. It also makes it weaker and has a lower melting point. But if we want flexibility in our material, then they're really useful. So these are plasticizers. They make the intermolecular forces go down, so they're weaker. The material is more flexible, but weaker with a lower melting point. So those are plasticizers. The other way that we can change the properties of a polymer is to add something called crosslinks. Now, crosslinks are bonds that form between the chains. So you're making the intermolecular forces much stronger. So here I'm adding some more bricks to work as crosslinks. So I have increased the strength of my intermolecular forces. That makes the material stronger with a higher melting point, but it's much less flexible, it's much more stiff. If you look at it now, the chains cannot slide past each other because there are the crosslinks there. So in order to slide the chains past each other, we need to break the crosslinks, which is harder to do. And that makes the material stronger with a higher melting point, but less flexible. So these are crosslinks. They increase the intermolecular forces. So the intermolecular forces go up. The material becomes stronger. It has a higher melting point, but it is less flexible.